So in this video we're going to introduce orthogonal trajectories. So the idea is that we want to find two families of curves that are orthogonal or perpendicular to each other. So for example, if I'm given the family of curves, the set of all circles centered at the origin, and I've drawn 1, 2, 3, 4 members of that family, there are infinitely many members of that family, and they would have the form x squared plus y squared equals c, where c would need to be some non-zero constant for it to be the set of all circles centered at the origin. And the idea is we want to find a family of curves that is perpendicular to this family or orthogonal to this family. So what are the orthogonal trajectories to the family of curves, the set of all circles centered at the origin? And it turns out that it's going to be the set of all lines centered at the origin. So here's, I'll put constant 1. So the set of all lines, y equals mx. This is the set of all lines centered at the origin. This family of curves is perpendicular to the set of all circles centered at the origin. So I've drawn in a few lines centered at the origin, and the key is that if you take any one of these lines, it doesn't matter which one, and you look at their intersection with any circle, so mark that point of intersection, and then draw the line tangent to the circle at that point of intersection, we'll see that the line through the origin is perpendicular to the tangent line to the circles. So the idea is if two families of curves are orthogonal to each other, then their derivatives must be orthogonal to each other, because the derivatives represent the slopes of the lines to those curves at any given point. And then what we want to do is take advantage of what we know from algebra. So for example, if we had the line y equals 2/3 x plus any y-intercept, if we wanted to find a line perpendicular to this one, we would need to use a line whose slope was the negative reciprocal of this line, so plus b sub 2. So what we learned in algebra was that any two lines, if their slopes are negative reciprocals, then they're perpendicular to each other. So the slope of this line has to be the negative reciprocal of the slope of the line that's tangent to the circle. And that's kind of the key concept that's going to allow us to find families of orthogonal or perpendicular trajectories. So for example, it says find the family of curves orthogonal to the family of curves given by y equals c over x, where c is any non-zero constant. And we could look at a few members of that family if we wanted to. Here's what they look like. Y equals 1 over x is right here. Y equals 2 over x, y equals 3 over x. So this should be a family of curves that you looked at in a pre-calculus class. And it's infinitely many members of the family, and what we want is to find another family of curves where any given member of that family is perpendicular or orthogonal to any member of the family y equals c over x. And what we'll do is calculate the slope of the lines that are tangent to the curves y equals c over x, and then we'll determine what the negative reciprocal of that is, and then we'll find the function family whose derivatives represent the negative reciprocal of this function family. So we need to find dy dx. And with these, you can kind of get yourself in a pickle. So the easiest way to find dy dx isn't going to be the most convenient way to find dy dx. So for example, if I just calculated dy dx here, I'm going to wind up with c, and then it's going to be the opposite of c, x to the negative 2. We'd wind up with this type of thing. And it's going to turn out that having this constant right here, this non-zero constant, involved in the derivative is going to complicate matters. So what we want to do is find dy dx in a way that eliminates the non-zero constant c for us. And the way that we can do that is just multiply both sides by x times y, so that x times y equals c. And then implicitly differentiate the left-hand side. And the reason for doing this is if we take dx of both sides right here, then d dx of a constant is going to be 0, and we've eliminated that non-zero constant. We've eliminated our need to have to deal with that non-zero constant by finding the derivative this way. So here I have the product of two functions. So to take the derivative of a product, I would just take the derivative of x times y, which is going to be 1 times y is y, and it's going to be plus the first function x times the derivative of y. The derivative of y is just going to be dy dx, and now we can solve this for dy dx. So we get x dy dx equaling the opposite of y, and then dividing both sides by x, we get dy dx equals the opposite of y over x. So every member of this family, y equals c over x, will have a derivative that's found by taking the opposite of y over x. So the slope of the tangent lines to this family of curves are given by this derivative. So this is our family. This is fam bam 1 right here. So the family of curves, call it family 2, that's orthogonal to this family, will need to have slopes or derivatives that are negative reciprocals of negative y over x. So their slopes or derivatives will need to look like this. The negative reciprocal of negative y over x is just x over y. And now I can separate variables. So I can do multiply both sides by y. I get y dy equals, multiply both sides by dx, I get x dx. Variables have been separated, integrate both sides. We get a constant of integration that is not this constant. So maybe I'll subscript him with a 1 to discriminate him from the c that we started with. And now we just integrate. We get 1/2 y squared equals 1/2 x squared plus our c sub 1. Multiply both sides through by 2, we get y squared equals x squared plus 2 times c sub 1, but 2 times c sub 1 is still just some constant. And then if I subtract x squared from both sides, hopefully this helps me to recognize what this family of curves is. These look like hyperbolas. Y squared minus x squared equals c squared. It looks like the family, as long as we let c be a non-zero constant, looks like a family of all hyperbolas. And so that's so the hyperbola family is the family of curves orthogonal to this family of curves. And if I look at the graph in GeoGebra of a few hyperbolas, you can see that it even is visually apparent that the hyperbolas are meeting the c over x guys at right angles.